Balancing redox reactions requires a certain number of steps to be followed, and these reactions require these steps because they are more complicated than just balancing by inspection alone. The first step always is to write half reactions. So a few things that we need to do to write the half reactions: we need to assign oxidation numbers so we can identify what's being oxidized, what's being reduced. We then separate it into the two half reactions or half equations. These words are interchangeable. Finally, we're going to balance each half equation or half reaction by adding electrons to the side with the more positive charge. And finally, we're going to double check each half reaction to make sure it's balanced in terms of both its atoms and its charge. From there, what we're going to do is combine the half reactions together to get an overall balanced equation. We're going to make sure that the number of electrons in the two half equations are equal. If they are not, we are going to multiply the equations by whole number ratios in order to make them equal. And finally, we add the two half reactions together, canceling out anything that is the same on both sides of the reaction. We have a pretty easy example here. We've got zinc plus copper 2 plus reacts to give zinc 2 plus copper. If we do the oxidation numbers, zinc goes from 0 to +2, increasing a number that would be our oxidation. Copper goes from +2 to 0. It's going down. That is our reduction. So now what we want to do is write out our two half reactions. The first one we'll do is zinc to zinc 2 plus, or that is our oxidation. We then want to add electrons to the side with the more positive charge to balance the charge. Because we've got a zinc 2 plus on this side, we're going to add 2 electrons so that the charge balances out to 0, which is on our reactant side. Our second half reaction, copper 2 plus, reacts to give copper. We're going to add 2 electrons to the reactant side because of that +2 charge, and now that's balanced by both number of atoms and number of electrons. We're going to double check that the number of electrons lost by zinc is the same as the number of electrons gained by copper, which it is. So from here, what we can do is add the two equations together to get our overall balanced equation. We're going to get rid of anything that is the same on both sides. So those 2 electrons are going to cancel out. You know you've balanced right if they do cancel out. You don't want to be left with any electrons in your final balanced equation. So that equation there was actually balanced before we even began, but we could double check this. The overall charge of the reactants should equal the overall charge of the products, and the number of atoms should be equal on both sides as well. So this one is balanced. Many complicated redox equations take place in acidic solutions, so we need to account for that in our balancing process. And there are a few extra steps that we need to perform. We're going to start off again by assigning oxidation numbers and separating them into two half reactions. From there, the steps differ a little bit. We are first going to balance all atoms other than oxygen and hydrogen. Once we've done that, we're going to balance the oxygens by adding water to the side that requires oxygen. We're then going to balance hydrogens by adding H plus to the side that needs it. We're going to balance the charges by adding electrons to the more positive side. And we're going to double check that each half reaction is balanced in terms of atoms and charge. From there, we have the same steps as before. To combine the half reactions, we have to make sure the number of electrons are equal in our two half reactions. If not, we're going to multiply each half reaction by simple whole numbers to balance the electrons gained or lost. And then add the two half reactions together, canceling out anything that's the same on both sides. Here's an example problem here. We're asked to balance this equation here. Fe2 plus the dichromate ion reacts to give Fe3 plus Cr3 plus. And it tells us that it happens in an acidic solution. Let's start out then just by writing out our two half reactions. So we know this is +2, that's +3, that's +3. Oxygen is a -2. -14, that makes our chromium +5. No, +6. I apologize, +6. So that makes 12, and 14, that would give an overall -2 charge. Good. Okay, we've got two half reactions then. We've got our Fe2 plus going to Fe3 plus, and we've got our dichromate going to Cr3 plus. Focusing on the first equation, we've got Fe2 plus reacts to give Fe3 plus. Let's follow our steps then. We're first going to balance our atoms, which are already balanced, other than oxygen or hydrogen. We don't need to balance oxygen, and we don't need to balance hydrogen because there aren't any in this half reaction. So all we need to worry about here is the charge. And we're going to add one electron to the product side so that the charges balance. Our second half reaction is going to require a few more steps. First thing we want to do is balance our atoms. You notice there's 2 chromium on the reactant side, so we're going to put a 2 in front of our chromium on the product side. Our next step is that we want to now balance the oxygen. There are 7 oxygens on the reactant side, so we're going to add 7 waters on the product side in order to balance those oxygen. Finally, we want to balance hydrogen. We've got 14 hydrogen on the product side. We're going to add 14 hydrogen to the reactant side. We now need to decide how many electrons to add. So let's look at the total charge on the product side is going to be +6 because we've got 2 Cr +3s. On the reactant side, we've got 14 plus and then a 2 minus, so that gives us an overall charge of +12. We're going to add then 6 electrons to the reactant side in order to balance that charge. Our next step then, we need to make sure that the electrons match up, which they don't. So what we need to do is multiply this top equation by 6 in order for those 6 electrons to cancel out. So let's just do that in front of each one here. We're going to write a 6, and then change that to 6. Now we can add everything up. So let's add up what we've got on our reactant side. So we got 6 Fe2 pluses. Those 6 electrons cancel. We've got a Cr2O7 2 minus. We've got 14 H pluses. That's going to react to give 6 Fe3 plus 2 Cr +3s plus 7 water. The last thing you want to do is just double check. Make sure all the atoms add up properly and that the charges on each side are also balanced, which this is.